Hey, hello there, and welcome back. So it's been a while since I've recorded anything, and actually it's been a while since I've done any programming. So I figured, why not get back to that, doing some advent of code, which I have not done since the beginning of the year. And I just spent some time configuring something on OBS to record. Let's see if this works. Actually, I had to switch off Wayland or change from Wayland desktop to Xorg. To be honest, I have no idea what Linux compositing, or is that the compositor or something, or the display server or whatever. But the problem was that in Wayland, I have basically a window here that you cannot see, but I'm seeing this window to see where my webcam thing sits on OBS. So I remember that my face is there, and that wasn't working on Wayland. It wasn't staying on top of other windows, and also the shortcuts weren't working. So it was like, awesome. I seem to remember that Wayland was supposed to be the future of Linux desktop for a while, and still it's not really as capable as Xorg, it seems. But anyway, I seem to be forgetting how to speak, and also I have no idea where we were in Advent of Code. So let's see. Day 18, boiling boulders. Where were we actually? In a volcano or something like that? You and the elephants finally reach fresh air. Okay, I had forgotten that there were any elephants. What was the previous day actually? 17, pyroclastic flow. Oh, this one was the one of the Tetris pieces. This one was cool and actually pretty difficult, if I remember, like the second part where it was like kind of infinite or super tall, and you had to find cycles or something like that. So, okay, let's see if let's see what day 18 is about. So actually I need to read this. You and the elephants finally reach fresh air. Nice. You have emerged near the base of a large volcano that seems to be actively erupting. Okay, not nice. Fortunately, the lava seems to be flowing away from you and towards the ocean. Bits of lava are still being ejected toward you, so your shelter in the cavern exits a little longer. Outside the cave, you can see the lava landing in a pond and hear it loudly hissing as it solidifies. Depending on the specific compounds in the lava and speed at which it cools, it might be forming obsidian. Wow, nice. I think obsidian is also like a node taking up that is getting some hype at the moment. Anyway, the cooling rate should be based on the surface of the area of the lava droplets. So you take a quick scan of a droplet as it flies past you. Your puzzle input. Okay. Because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low, and as a result, it approximates the shape of the lava droplet with a 1 by 1 by 1 cube on a 3D grid, each given as its XYZ position. Okay, so these are 1 by 1 by 1 unspecified units, cubes, like it could be meters, centimeters, I don't know, inches, whatever. To approximate the surface area, count the number of sides of each cube that are not immediately connected to another cube. So if your scan were only two adjacent cubes like 1, 1, 1 and 2, 1, 1, each cube would have a single side covered and 5 sides exposed, a total surface area of 10 sides. Here's a larger example. Okay, and we have this lava droplet example. In the above examples, after counting up all the sides that aren't connected to another cube, the total surface area is 64. What is the surface area of your scanned lava droplet? Okay, and here's the input. which is just a bunch of points. This actually seems pretty straightforward for part 1, so I'm already a bit apprehensive of what may come in part 2. But at least part 1 seems pretty straightforward, I think. And the lava droplet is like the real input are more points, but the points are pretty low coordinates, it seems. Like nothing seems to be above 100 or even above 20. So that's nice, I guess. We can probably get by using like a 3D fixed array of 100 or something like that, or 50 or whatever. So anyway, let's jump back to the code. I don't remember anything basically. Advent of Code 2022. Yes, we are continuing Advent of Code 2022 in the middle of 2023. All right, let's make a new file. Or no, actually, how were we doing this? Let's go to open file is ready. I don't want to open a file. I want to go to main and see. We're gonna do day 18. How was this code? Boiling boulders. This reminds me that today I want to go bouldering and it's already a bit late. So let's try to do part 1 and cut it off. So gonna import this module, and then here we're gonna add the run function. Can the language server like create this file? We're gonna create this .rs. I hope I'm increasing the font size because I'm using my laptop screen and I don't see it too well. So this is a public function run. Trying to remember how we were doing this. Input was a string slice, and the output was a string, if I remember correctly. So let's do this. It doesn't complain, and if we do cargo run 18, well, I think it ran error. Oh, it's complaining because we don't have the input, of course. Let's create an input file. Day 18 txt. And let's actually copy the sample input for now. And let's run again. Awesome. Okay, so what do we want to do? I guess we can start by reading the file. I don't remember. I remember very little, to be honest. How were we doing this? Let's see. Let's think of what we want to do. I think we have these points that represent the lava droplet, and we can, I guess, do we need an actual grid? Because putting this on a grid, we would have to do like bounce checking and things like that. I think we can do it very, let's start by doing this the simplest way possible, which would be having a, let's say, droplet points. It's going to be a hash set of points. And this is going to be input lines, then map, and we can have like a parse point function and then collect this thing. Yeah, why not? Okay. Import this, of course, and let's keep returning this for now. The point, come on, language server, you can, let's say that the point is just a tuple of, do we care about signs? I think we don't care about signedness or anything. This could actually be like bytes, I think, but let's not optimize in part 1. And of course, the language server also doesn't know how to declare a function, so parse point is going to take a string slice and return a point. Yes, okay. Actually, I think if we do this, we don't need to say here. Like we can get the inference works for us. And how do we parse a point? I guess we can split. There was a split once, but also, is there a split n? Split one. I guess we can say split by this. And if we do something like let numbers be numbers of type let's try this. Like, let's parse this into a fixed array of size 3. So we're gonna have split and then map this to, well, maybe s is not the greatest number here, but let's say parse, and finally try into, I think. Let's see. Does this work? Okay, and expect. Try into. No, I think we need to collect first into a vector or something like that. Okay, no problem. I guess we can collect these numbers into a vector of I32. So yeah, parse blah blah, collect. Oh, and I think we need to parse and expect here. Invalid number, let's say. All right, something like this does work. And actually, before it was, I don't know if it was complaining because of this missing expect here. So instead of collect, let's say try into again. Let's wrap. No, I guess it doesn't like this. Interesting. Okay, let's keep it simple and collect things into a vector. Should be no problem of the extra allocations here. And let's just return, we can call this thing shorter variable, ns. And let's have ns0, ns1, and ns2. This is not the greatest code, but let's see if this actually works. Let's print line this droplet points. Of course, this is complaining about what? Yeah, display. How was this thing done? Something like this. Yeah. Okay. Let's run this. Okay, it seems to be working, right? Day 18 txt. Okay, we have the parsing code 226. Wait, does this actually 1 to 5? What is this parse? Oh no, we are collecting into a hash set, so it's not ordered. Okay, fine. Okay, we have the points. So are these points? Well, this represent cubes, but let's see. We have to calculate the surface area, or I guess the exposed surface area. That's what it was called. To approximate the surface area, count the numbers of each cube. They're not even okay. Exposed. Okay. So let's say total area. It's gonna be the droplet points. Let's iterate into this. Let's map this to the area of each cube, and then sum this. And then we are just going to format the total area. Okay. And this, we're gonna have a point, so I guess we can have x, y, z coordinates. And then do we get what we want here? Yeah, can we dereference here? Yes, okay. We have the x, y, z. What do we need to do? Let's see. Let's say the connected cubes be, and here I guess we can say x plus 1, y and z, then x minus 1, y and z, then we're gonna have similar thing but with y, then a similar thing but with x, with z I mean. So these are the neighboring cubes, and we want to what? Filter? No, we want to let's say iterate this and filter the ones that are connected. So how do we do that? Let's say neighbor, and we can ask if the droplet points has or includes. How do you ask if this is a hash set key? Contains, yeah, contains the neighbor, yeah, just neighbor. Okay, this neighbor is, oh, this shouldn't be this should be tuples. Very good. And then finally count how many of these are. This is gonna be, whoa, what happened there? Come on, don't. Let's say that the area is 6 for now, so it doesn't reformat to something stupid. Okay, these are the connected cubes. think that there is something not working fine with my Rust setup here, because it's not complaining about this unused variable. But let's say 6 main minus connected cubes count. Okay, total area. Yeah, total area should be, I don't know, whatever, use size, say. Yes, okay, does this work actually? Actually, this worked. Okay, I felt very rusty writing that, but apparently, you know, at least for the sample input, I wasn't so rusty. So let's copy the real input now and try it out. And we have this number for the total area. So let's see. It's been so long. Okay, so we got one golden star. Nice. Okay, that was a good start. I'm dreading to read part 2. I'm actually wondering if I should stop now. No, okay, let's read it, and if it seems too daunting, we'll stop the video and continue afterwards. So, part 2. Something seems off about your calculation. The cooling rate depends on exterior surface area, but your calculation also includes the surface area of air pockets trapped in the lava droplet. Instead, consider only cubes in cube size that could be reached by the water and steam as the lava droplets tumbles into the pond. Okay. The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplets, but never expanding diagonally. What? The steam will any air on the outside of the lava droplets of exactly 1 cube of air is trapped within the lava droplet at 225. So the exterior surface area of the lava droplet is 58. Okay, so there are cubes, I guess, that are not part of the droplet. Yeah, of air is trapped within the lava droplet. Okay. So yeah, it is more complicated than what we were doing. I did not really understand what this part of the description is saying. The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet. On the outside of the lava droplet. But never expanding diagonally. Like, I don't understand what this means. Could be reached. What I'm interpreting from this is that there are some air pockets inside the droplet. So we have to find those, either doing some kind of like fruit filling algorithm or something like that. I'm not sure. But basically, we don't have to count those sides. But anyway, I think I'm going to stop the video now because I want to go and do some climbing today. So if you haven't, thanks for watching, and hopefully we'll see you soon. Bye bye.